Every challenge question in the textbook, part 9. This is the binomial chapter. Now, to get a constant term in this expansion, I would need twice as many of this term as this term, because that would cancel all the x's if there were like 2 of these and 1 of these. And that's actually the only way to do it, because there's only 3 things you're allowed to choose in total. So taking 2 of those and 1 of those would do it. So that's 3 choose 1, 1 of those, 2 of those. 3 choose 1 is 3. This doesn't provide a number. Minus a half to the power 2 is positive a quarter, so this makes a coefficient of 3/4. I'll do this question in a different way later on, or a similar question in a different way, I should say. N choose r is of the form this, so therefore 10 choose 3 is 10 factorial over 3 factorial into 10 minus 3 factorial, which is of course 7 factorial. So that makes this, because the factorials are when you multiply the number by every integer below it down to 1. But notice how this, and then 3 factorial is just 3 times 2 times 1, which I've just instantly written as 6. Notice how all of this cancels all of this, so all we've actually got to do is 10 times 9 times 8 over 6, except 6 is 3 times 2, as we said. Cancel the 2 with this to make this a 4, and cancel the 3 with this to make this a 3, and all you actually have to do is 10 times 3 times 4, which is 3 times 4, which is 12 times 10 is 120. And then when you do 10 choose 7, you replace this with a 7 and this with a 10 minus 7, which makes 3. But now you're doing 10 factorial over 7 factorial times 3 factorial, which I think is going to be the same as 10 factorial over 3 factorial times 7 factorial, because multiplication is commutative, so this is obviously going to be 120. And then for some reason they asked me to do that again. Great, fine, whatever. This cancels with this, obviously. 5 times the 2 that will be in here will cancel with this 10. And then the 3 times the 4 in here will cancel with the 12 up here. So all that's left here is 14 times 13 times 11, which you can work out to be 2002. And then, of course, the other one, which came up early for some reason, is the same, because this 5 goes here and this 9 is here, and it's obviously the same thing. What do you notice about these two things? Yeah, I've already said so. Prove that this equals that. Well, okay, well, by definition, this is that. And this one, you just replace this first bit with an n minus r, and the second bit with n minus r. But n minus n is nothing, and then minus r is plus r, and you end up with this, which is equal to that. And so therefore the two things are equal. I don't think that was really worth a challenge question. So this you could do with Boston binomial, but of course you could also do it by just noticing that's a difference of two squares. So I'm just going to factor this to be, so x is taking the place of a plus b, and y is a minus b. So this is going to factorize to x plus b all squared minus x minus b all squared. Sorry, a plus b all squared minus a minus b all squared into a plus b all squared plus a plus b all squared, which of course expands out. You could even factorize this again, although I don't think it's particularly helpful or necessary. The a squares and b squares cancel here to leave you with this, and then nothing cancels here except the middle terms, which is nice because you get this, factorize out the 2, and you get what they wanted. Now this, again, you could just use difference of two squares stuff, and it's arguably quicker. You could also just do a prime factor tree, which again is arguably quicker. It doesn't say the word hence, so you could do whatever you wanted. But if you were intending, or if you were really super keen on using this previous section here, you just need to notice that power 4 minus power 4, what is taking the place of a and b here? Well, the average of 17 and 5 is 12. So therefore 12 plus something and 12 minus something will make these two numbers. And of course it's 11, isn't it? Because they add up to 22. Because the average is 11. So of course 11 plus something and 11 minus something makes these two numbers, and that number is 6. So you can write it like this. And then of course you can just say, well, a is 11, b is 6, and that goes into here. So you get this. 6 is 2 times 3, and this is 100 something. 2 times 3 can be distributed out to here to make these primes, and 157. You just need to check that's not prime, or sorry, check that it is prime. It's clearly not divisible by 2 or 5 or 10 or any of the obvious primes. 10's not prime. It's not divisible by 3 because the digit sum isn't a multiple of 3. 7, if you double this last digit of 14 and do 15, take away 14 is 1, so that's not in the 7 times table, so no. And 13 goes to 130, 27 above, so it can't be 13. I think that's all the primes you need to check. So this is prime, and therefore that's the answer. Next one then, find the coefficient x to the 4 here. Well, this is, I don't know why this is a challenge question in any way. To make x to the power 4, you need 2 of this term. You have 9 things to choose in total, so therefore you need 7 of this term. So it's 9 choose 2 or 9 choose 7, as we saw before. It doesn't make a difference. You have 3 to the power 7 and minus 2x squared to the power 2. And yeah, you just type, well, minus 2 squared is 2 times 3 to the power 7 times 9 choose 2, and you get this coefficient here. And then this one, yeah, this is similar to the first one. at the top of the video, I'm going to do it a bit differently. I'm going to factorize out a 1 over x term from this bracket here, just because when you're trying to find x to the 4 terms, this, because it's essentially x to the minus 1, starts cancelling things down. So if you just take the 1 over x like this out, and then of course this power 8 distributes between the two factors here, so it's 1 over 8 x to the power 8 times this to the power 8, like this. Now, if I'm trying to get x to the 4 terms, I need this to provide x to the 12 terms, because then divide by x to the 8 and you get x to the 4 terms. But this is much easier to think about how I need x to the 12 terms. I need 4 of those, because of course x to the 3 to the power 4 is x to the 12. And of course, if I'm taking 4 of those, then I need 4 of those, because there are 8 things in total. So this is 8 choose 4, 5 to the power 4 times this to the power 4, not that it matters because it doesn't provide a coefficient. And just type this section in, and you'll end up with this number here. I think this was the last one. It's weird. This is a challenge question because this is actually just a very standard question that they ask in A-level exam papers a lot. Now, to make x squared terms, in fact, I don't think this is actually the last question. I think there's one after this. To make x squared terms, I can either do 2 times an x squared term coming from here, or I can do minus px times an x term coming from here. So the only things I'm interested in from this are the x terms and the x squared terms. So let's work those out. So the x terms are obviously this coefficient here, where you take 4 of these, 1 of those, with a 5 choose 1, and that makes this. And the x squared terms are when you do 5 choose 2 and take 3 of those and 2 of those, and you get this coefficient here. So that's all I care about. I don't care about the other bits at all because we can't get lower x's. X to the 3 can't magically become an x squared anywhere. I'm trying to show that there are no x squared terms, so I'm trying to get these things to cancel. So therefore I need 2 times this, which is 540x squared, plus this times this, which is 405p x squared. I need those to cancel out, and I don't care about anything else. So this minus this must be 0, and we end up with p is 4/3, which is showing what they wanted us to show. A very similar thing here, I guess, coefficient of x squared. Again, I either need, there's a few things I need here. I either need constant terms from this one to times by x squared from this one. I need x terms from this one to times by x terms from this one, or x squared terms from this one to times by constant terms from this one. So let's just find those 3 things. So what I'm going to do is I'm going to expand each of these 2 things out up to the x squared term, because I need all 3 from the constant 1 and 2 from each bracket. So let's just do that. This is a very easy expansion to do. Done it a few times now, stuff very similar. So that's the first 3 terms. And essentially, I only care about this expansion here. And even more specifically than that, I only care about what's 1 times this, because that will make an x squared, plus this times this, because that will make an x squared, plus this times this, because that will make an x squared as well. I don't care about anything else, because like this times this makes x cubes, and anything bigger than this automatically makes things bigger than x squared. So yeah, don't care. So anyway, this times this is that, this times this is that, and this times this is that, and they all cancel out or kind of do this and combine to make this. And I think that is the end of this chapter's questions. It is. Good. I'll see you for the next part.